Thank you for joining us as we explore the benefits of using Vectorworks Landmark for your 2D and 3D landscape-specific design, modeling, and presentation workflows. Almost immediately, you'll notice that the user interface in Landmark is designer-friendly. The workspace presents fundamental and industry-specific tool sets ready for your use, and a WYSIWYG design environment that displays exactly how your design will look and scale. You'll quickly become accustomed to the design layer and sheet layer organization method, which isn't so different from other design software options you may have used already. One of the first questions to answer when evaluating the software is how best should you start a project? Landmark's flexibility means this can be answered in several different ways, but there are two main approaches to consider. The first is to start from scratch by accurately drafting in your site's base plan from field measurements you've acquired. The second is to import a background file such as a PDF, DWG, or geospatial files from your collaborators. Imported DWG files provide immediate access to base file geometry such as property lines, existing and proposed buildings, and pavement, topography, vegetation, and other essential data. Importing GIS shapefiles or enabling the new GeoImage feature allows a project to take on its surrounding real-world context quickly, which is an incredibly helpful way to begin a landscape project. With imported geometry, take note of Vectorworks' hybrid 2D-3D workflow. You can begin converting the geometry to hybrid and smart objects as early as the first import. Do this with flat contour lines, for example, for a good start at a 2D and 3D represented terrain model. This hybrid workflow yields particular benefits as we start getting into pre-development analysis. And unlike traditional CAD and modeling workflows, in Landmark you can supplement your newly made site model with smart water flow and slope analysis features, which are ways to visualize crucial site data. Easily conduct sun and shade studies with the georeferenced Heliodon tool. And when considered in conjunction with the site's building massings and the existing ground surface, the Heliodon enables live simulations at any time of day. There are many more possible analysis opportunities in Landmark, but the few I mentioned are great examples of how the software helps site designers make better decisions in planning for better performing landscapes. Let's talk a bit about what Landmark's BIM support means for the landscape professional. It's easier to design a landscape around or on structures when you include their schematic massing model or the architect's BIM model. Vectorworks Landmark has long been supportive of importing and referencing BIM files in the industry standard IFC format. The recently added ability to import RVT and RFA files means you're already fully ready to import the work of your collaborators. With full ability to manage visibilities and regular revisions to the building model, Landmark helps the site stay responsive to the design team from early concept through design development. Speaking of concepts, our users still enjoy maintaining a traditional sketching workflow as they begin their design process. After bringing sketches into Landmark, users can trace those sketches with polyline tools converted to smart objects like hardscapes and landscape areas. And these objects can begin as unstyled and data-free or as intelligent as you desire. Contour lines and other shapes can be manipulated to become site modifiers, which grade the surface. Once users become proficient, they can directly create these smart objects with the tool of choice, like we see with the fence tool. Landmark offers a suite of BIM tools that are purpose-built for the landscape. The Landscape Area tool creates an area in both 2D and 3D, which can represent planting. It can also represent surface and subgrade material for planting beds, as well as other designations for space on a site. And the Plant tool creates a hybrid placement of individual, hedged, and grouped plantings with singular plants. And both of these tools account for the material they specify within their own labels, worksheets, and data tags. Another BIM feature, the Hardscape object, is a great example in how these objects have parametric components, which are quantifiable with pertinent data like area, perimeter, and volumes. Once created in the user's design, these materials are immediately reportable within Landmark's built-in worksheets to perform quantity takeoffs, opinion of cost estimates, and other needed analysis, all without having to go to another spreadsheet software. This is why objects like plants have many data fields to accept this information and parameter settings so that they can be included in planting schedules and other reports. Aside from reporting the data included in your design, Landmark intuitively displays material data with data visualization. So as the design develops, site designers can create and save fill and pen override settings for these visualizations to verify decisions as they design. Or they can include them in the sheets they share with clients for highly visible and easily communicated presentations. As projects move into their construction documentation phase, Landmark users rely heavily on features like title blocks and sheet layers to organize and prepare their well-documented project for delivery. Within this documentation, coordinating and updating notes is made easier with features like callouts and legends. And data tags enable the creation of labels to consistently call out materials, quantities, and other specified details to accurately document with the designer's customized treatments to those labels. Though I've already mentioned worksheets, it's important to note their bi-directional updating capabilities, which means as changes are made in the project, they update with each recalculation, intuitively pushing changes made within the worksheet back into the project, updating labels, data tags, and associated records with each update automatically. As your file migrates from design development to construction documents, smart objects like the site model continue to communicate graphically and informationally. Your grading changes are reflected in proposed contouring, which then aids in verifying proper slopes with color analysis and cut and fill reports for the excavation required. You'll enjoy the way tools like the grade object, which offer point-to-point grading, are purpose-built to report the changed elevations and slopes, which you need for documentation anyways. As you add annotations for each project's layout plans, the customizable dimension tool provides quick assists in noting lengths and angles. And the stake object is perfect for spot elevations and coordinates. As firms go further with detailed views and installation details, not only will these annotative tools continue to be useful, but scaled viewports and coordinated markers help extend the use of the BIM model in all aspects of documentation, so that when a change is made in one area, its results are efficiently seen throughout. When a designer decides to provide cut sheets or manufacturer-provided details, this is well supported by importing and referencing their images and PDF files. So as the project matures, it's important to be able to share this ever-progressing BIM file for verification and clash detection. For this, Landmark users can confidently share IFC, RVT, and other 3D model file formats to meet the requests of the firms they work with. As you can see, there's a great deal of benefits using Vectorworks Landmark, and I've just scratched the surface. I invite you to visit our Vectorworks University to learn more about these tools and more. That's university.vectorworks.net. Feel welcome to contact us with any further questions you might have about Landmark.